Hello, everyone. Some people say that besides running the DevFest, I know a little bit about development. And today we are going to talk about cross-platform development. To start with, let me know who of you is working with any kind of cross-platform tools like Xamarin, PhoneGap, or anything that we call cross-platform tools. Not that many, OK. Who of you like cross-platform development? Any hands? OK, I see one hand. I see two hands. OK, it's not that good as in other audiences, but we are doing great. Based on the statistics, we can say that cross-platform development is freaking hard. And today I want to share with you experience that we got at GetSocial, learning from Google how to do a cross-platform development. Probably everyone knows about Inbox. And when Google just released it, they published as well a huge blog post about how did they achieve a 70% code sharing between Android, iOS, and web platforms. To achieve this, they developed a tool called J2ObjC, and we are going to talk about it exactly about this. Besides Inbox, Google is using J2ObjC for almost all their Office apps, including the latest app Do that they released a couple of weeks ago. Besides Google, this project, J2ObjC, is used by around 25 other projects, and we can say it's not that popular. That also means that community is not that vibrant, but it's getting better, and more and more people are getting excited about J2ObjC, and today I am going to try to get excited you about J2ObjC as well. OK, let's move on. Now I'm going to share a bit our problem we try to solve at GetSocial. We are a Dutch-based startup. We are building an SDK. We help developers to solve their problems with user acquisition, user retention, and monetizing their users. We have built-in chat, newsfeed like Facebook has, and we can run promotions on activity feed. Our SDK is available for 4 platforms. Marmalade is coming, but today we are going to focus on Android and iOS. Just a bit of statistics on which scale we are working. So far, we have around 50 games integrated. From our clients, you probably know Angry Birds. So we integrated into almost all Rovio titles, also Wargaming, Glue, and so on. Each month, we serve around 30 million users. When you serve on such huge audience, your SDK should be perfect. It should be fast, it should be maintainable, and easy to use. And around the year, we serve around 500 million sessions. Just to show our reference architecture for other cross-platform SDKs. Currently, we have separate Android SDK and iOS SDK. Android SDK built with Java, and iOS SDK built with Objective-C. All other SDKs are just thin wrappers on top that expose interface comfortable for target developers. For instance, for Unity, we have thin layer bridge on Unity side that expose C# API. The good thing with this approach is that we can use all platform features. Like, we can use native UI tools, we can use all language features, and so on. But that's the only benefit. If you are looking for drawbacks, we are building exactly the same SDK twice, because functionality should be exactly the same. And we do at first work on Android in Java, and then later on iOS. Second problem we faced with this approach is it's very hard to keep API in sync. All developers are unique, and our product owners are lazy. They don't like to go into deep details and define all corner cases in the specification. So we faced with a situation when default flow had exactly the same behavior on both SDKs, but corner cases had different behavior. And we decided to solve this problem. We decided to implement the idea that Sun Microsystems or Oracle is pushing for the last 20 years. Let's write code once and run everywhere. And we looked into tools that are available in the market. But before looking into them, we set requirements we want to get at the end after doing such a big work. All our tools should be performant, so our user experience should be insanely good. It should be fast, it should be reliable. It should be easily maintainable. So by maintainability, I mean set of tools we use and tools like IDE, testing tools, and so on. The approach we are going to select also should add very small size footprint to our SDKs. And it should be kind of open source or free, because we are serving SDK and relicensing won't be an option for us. So we looked at the market, and from all tools that were more or less suitable, only J2ObjC was satisfying all our requirements. Xamarin wasn't not an option because it's a C# framework. RoboVM spinned up a virtual machine on iOS, and it required extra setup from developer. The closest one was XML virtual machine. They had an idea that any code base can be converted to XML, and from XML to any code base. But we found from our experiments that it's annoyingly unstable, and it produces a lot of issues. But J2ObjC was perfectly fine, and now I'm going to explain you why. So let's look closer at what is J2ObjC and how we can use it. Besides looking into what actually is J2ObjC, we'll cover how to configure a project, how to work with Objective-C from developer perspective, and what is impact on the team. So what is J2ObjC? First, and the most important point to understand, this is source-to-source compiler. It's not bytecode to machine code. It's source-to-source. That means that we can translate only Java to Objective-C, not Kotlin to Objective-C, not Kotlin to Swift, not Java to Swift, Java to Objective-C. No bytecode or any machine code involved. J2ObjC focuses on shared business logic, not on the UI. And J2ObjC is fully open source and published under Apache 2 license, which is perfectly suits to us. After talking what J2ObjC is, let's talk about what it's definitely not. It's not cross-platform application tool. That means it's not Xamarin that provides full stack from developing application from top to bottom. You won't be able to implement UI with J2ObjC, for instance. On the previous slide, I mentioned that J2ObjC focuses on business logic. That means that you will have to separate all your business logic into separate only Java module, and you will be able to cross-compile only this part. All UI should be developed natively. It's not Java emulator. As I mentioned before, we are cross-compiling from Java to Objective-C, and J2ObjC is compiled just handwritten Objective-C code on the iOS side. And it's not one-time source translation. That means that translated Objective-C code should not be modified. You do changes in Java code, and it automatically, or not automatically, depends on your setup, is cross-compiled to Objective-C. The official release happened half a year ago. Now we have version 1.1, as I remember. But the point is that it's absolutely stable, it's backward compatible, and that's the commitment that Google do. What is supported for cross-compilation? Because, as you can imagine, it's not that easy to implement all Java SDK, but most part is implemented. For instance, full Java 8 syntax. We can use all Java 7 platform features, and support for Java 8 is coming soon. All language features, like inner classes and arms annotations that are present in Java and not in Objective-C are also present. Cross-compiler handles this absolutely internally. Reflection is supported. All metadata is compiled and just inserted into generated classes into Objective-C, so you can access all this metadata. Also, besides translating your code, you can translate unit tests. And it supports OSNI code embedding. Here we'll stop for a second longer. Who has experience with with JWT. It's a web framework where you can write in Java and cross-compile to JavaScript. And remember, they had ability to embed JavaScript code into Java. J2ObjC supports exactly the same, but with Objective-C code. You'll just expose native code, and you just expose native method in Java side and put Objective-C code into special brackets. After cross-compilation, J2ObjC will translate message signature and insert this piece of Objective-C code directly without any translation. But remember, each time you are using OSNI, a small bunnies are dying somewhere in the forest. The main reason it's absolutely not supportable. The only place where we use it in our SDK is exactly for a cross-platform logger. For any other cases, we didn't find it's useful, and I don't recommend it to use for you as well. I have experience with JWT. It wasn't useful there, and don't use it here. Now let's talk about build configuration. First version of J2ObjC was released in 2008. And at that point, the only tool that was available is just a command line J2ObjC, where you can pass Java class, specify a class path, it do some translation, and at the output you get H&M file. It was pretty basic, but as you can imagine, using a command line is not that handy. At the moment, we have plugins for all modern and most popular build systems. Today we are going to focus on Gradle plugin because we are all Android developers and we all like Gradle. The good thing about Gradle plugin is that it was created by two absolutely brilliant engineers. Both of them are ex-Googlers. And if you'll check the code, it's really a state of art. Everything is perfectly documented, it's perfectly tested, and everything is available on GitHub. The only and the main drawback of this plugin is that it was not official. It was not supported by Google, and now it's not supported. Two of those guys, they have their own businesses and they have much more stuff to do, and a couple of weeks ago they announced that, sorry guys, we are looking for new repository owners because we don't have time. So it's not officially supported at the moment. The latest version that is officially supported by the plugin published on the GitHub is pre-release version. But it's not an issue, because you can create a fork and easily modify maximum available version for the plugin. Another big problem is the plugin is using Gradle 2.8. If you are following Android development, you probably notice that we've got some nice features like instant run and other stuff. And all these features are available only, they require plugin Gradle version 2.9 plus. The problem here is that in Gradle 2.9, Gradle introduced new project model that is absolutely not compatible with previous versions. That means that now, to support all the latest features in Android plugin, you have to update J2ObjC Gradle plugin, which is not that easy and requires quite substantial rewrite of the plugin. But if you're interested and want to use the latest version of J2ObjC plugin, check out our fork where we support the plugin, we support all the latest versions. As soon as we'll have time, we'll migrate to Gradle version 2. Actually to Gradle 3.0, because it's already released. Now with Android setup, it's pretty easy. You just enable J2ObjC plugin, apply it just like Android plugin, and it works, or almost works. With some magic it works, but we'll stop at it later. Let's talk about iOS project setup. We have two options how to set up iOS project. First one, we can automatically set up it via Cocoa Pods. Has anyone experienced with Cocoa Pods? I know, Max, you are an iOS developer. Good. So for those who don't know Cocoa Pods, it's just like Maven repository, but worse. iOS developers suffer a lot, but it's at least something. So J2ObjC Gradle plugin allows you to use Cocoa Pods, and it's pretty easy. Other option is to link libraries manually. The Gradle will generate static A libraries for you, and you have to configure your Xcode project manually just by specifying proper passes. The downside of both these approaches is that you won't be able to debug the generated code, because it's generated it's exposed to you as a static library, and only headers are available. And ideally, you don't have to debug it. But there are always cases when developers are that interested what the hell is happening in the code, and they want to debug on Objective-C side. Because if you have problem on Objective-C side, most likely you have the same problem on Java side. So first you need to dig in Java, and it's much easier. But we decided to fix that, because our developers are quite curious. If you look into default cross-compilation flow, we are translating, it's a bit simplified, there are like more than 7 steps. By the way, you don't have to take photos, the slides will be available right after the presentation. Java source code is translated to Objective-C source code, and then it's compiled to static libraries for different processor architectures. And after that, the static A libraries are linked to Xcode project. What our developers did, they replaced the latest step with Python scripts that generates Xcode projects from these Objective-C sources. In this way, it allowed us to debug all the Objective-C sources natively without any poor magic. And just a second ago, I mentioned that we have to compile a library for different processor architectures. And iOS so far supports around 4 or 6. Correct me if I'm not wrong. By default, it cross-compiles to 3 main platforms: for ARM processor, for 32-bit iOS processor, for 64-bit iOS processor, and for emulator, for x86. And cross-compilation takes quite a lot of time. It was an issue for us, and I want to talk with you about build time optimizations. First, and probably the easiest and the most effective, is to disable release build. J2ObjC uses the Gradle model to build. As in Gradle, you know that you have debug and release builds. So you can disable release builds because you don't need it during development. It will cut your compilation time for around 30%. Next, include only target processor architectures. For instance, if you are testing only on emulator, you don't have to build for all 3 default platforms. You can enable only iOS, x86, 64, and you will get extra 20% save time on a build. Also, we found useful to configure Gradle in a way so we can compile only iOS part, only Android part, and only shared part. Gradle doesn't support this by default, so you have to do all this configuration manually. By doing all these optimizations, we were able to cut our build time from 6 minutes to less than 2, which is not that good, and we have more ideas how to optimize build time, but we didn't implement it yet. We have to try it out before sharing our experience. Now let's talk about development process. J2ObjC documentation, J2ObjC Gradle plugin documentation advises you structure similar to this one, where you have shared module, where is your only Java code, where all J2ObjC configuration is located. You have separate set of libraries that you're going to cross-compile as well. You have iOS part and Android. Nothing special, just a Gradle multi-project structure. If you look to it carefully, probably it will remind you this guy. Who know him? Who can shout his name? Uncle Bob! Come to me after stage, I have a small gift for you. Looking into this folder structure, we can say that it kind of reminds clean architecture, where we have our business logic separated, our UI separated, and it actually is. J2ObjC forces you to clean architecture, or any kind of layer architecture. And if you look into default, like what Uncle Bob is pushing, it perfectly maps to our folder structure, where the main logic is fully in the shared module. In our case, we put all the framework drivers, like access to internal storage on Android or iOS, or access to the network into Android library project, and all the UI is, again, in a separate project. Talking about libraries. We are developers, we are lazy, we don't like to write code twice. We always use libraries. And J2ObjC allows you to use third-party libraries, but it requires sources. That means that you have to forget about any third-party proprietary libraries where you don't have access to the source code. Not all Java packages is implemented. If library is using anything from Java Neo or some parts of Java security, you won't be able to cross-compile this. And if you're importing library, besides sources, it's highly recommended to import tests as well, because cross-compilation is a tricky thing, and the only way to validate that cross-compilation happened properly and library has expected behavior on both platforms is cross-compile tests as well. And again, we have two options how to include libraries. First option is using pure magic from Gradle plugin. We just use specified dependency as we used to in our Java projects. And in J2ObjC config, we say, do the magic true. It will automatically pull the sources, pull the tests, cross-compile. You don't have to do anything. The only problem with this approach is that we managed to make it work only with JSON. For other libraries, or sources are missing, or they are published in a wrong format, so it doesn't work really well. But you have other options. You can include your library manually. If you remember, when I was showing project structure, we have a separate library folder where you can put just sources of library you are using, and in build Gradle file, you have to specify that cross-compile this library as well. So it's fairly easy to do, just requires extra step in a setup. And later on, you just include it as a normal project. Gradle plugin will copy the cross-compiled sources into proper places for you. So far, in the official documentation, they specify that following library is supported. So we have everything for unit testing, mocking, for data transport, for utility classes, basically all default Google toolchains they use for their applications. But our team found other libraries that we really like are missing. Like AssertJ, we were always using for assertations, it was missing. RxJava, with RxJava, it's tricky. You can cross-compile it, but some tests are failing. But our team is using shrink version of Rx, and tests for shrink version is working. So if you want to use the complete version of RxJava, you will have problems. But I know that the community is working to make RxJava working with J2ObjC by default. You can check the list of all deported and supported libraries by J2ObjC in this GitHub repo. They have continuous integration set it up that checks the compatibility of all new versions of the libraries on Travis CI. Continuing on testing, as I mentioned, testing is the only way to validate build logic of your cross-compiled code. That means that you have to have close to 100% coverage code. The downside of this, the testing is the only way to validate your code. So if you want a quick and dirty way to develop your cross-platform tool, J2ObjC is not the right approach. And it's very important, because from our experience, we found that some regular expressions are not working on Objective-C side after cross-compilation, and the only way how we were able to identify it is only by failing unit tests. From a toolchain available for testing, we are limited to JUnit 304. We have Hamcrest, but only core part, and we have Mockito. So basically, you have everything you need for testing. It's not the latest tools. It's not probably the best tools, but they are tested by the community. They are proven that they always will work, and Google is using mainly those tools in most of their projects. The bad thing that you won't be able to use our favorite tools. Like our team were not able to use SRJ. There are also some issues with cross-compilation. Gradle plugin is not yet smart enough to distinguish test classes and utilities for tests. So if you have a set of tests and some helper classes, J2ObjC Gradle plugin will try to run utilities classes as tests, and of course they will fail. To solve this problem, our team added a convention that classes that contain tests just have to have a test suffix, and a Gradle plugin you can specify a filter to run tests only on classes that specifies the file pattern. And there are some other issues like with threading. If you use thread sleep, for instance, in your test code, most likely your Objective-C tests will hang up. Now let's talk about pains of development on Objective-C side. As you know, Objective-C doesn't have namespaces. Namespaces, packages. So the only way to distinguish between classes after cross-compilation is name mangling. So if we on Java have our class in certain package, on Objective-C side, this package should be appended to the class name. As you can imagine, on Objective-C side, it's not very handy to use it, kind of. But we can help as developers. Oh, by the way, with methods happens exactly the same. As Objective-C doesn't support method overloading, if you have all parameter types are appended to method name on Objective-C side. So at the end, we get huge class names, huge method names, but we can help Objective-C developers. First, and the easiest way is to specify annotation with Objective-C name on top of the method or class. And this name will be used on Objective-C side. Second option is to provide mappings in the build configuration. It supports mappings for packages and mappings for methods. If packages mapping are fine, you just specify a pattern. You can specify, for instance, com.zasadnyy.**, and it will replace all packages behind, like that match this pattern with what you will specify. For instance, some suffix, like we replace all packages with GS, like GetSocial. With method mapping, it's much harder. And the main thing is class names and method names tend to change often. We like to refactor, especially on IntelliJ IDEA that supports refactoring perfectly. And all the method mapping should be specified just in configuration file, where you specify not even Java. Like you have to specify in configuration file GNI signature of the method. It's not very handy to write, but it's handleable. But problems with cross-compilation will be still there. So as soon as you refactor your method name, you'll change amount of parameters, you'll break this mapping file. We tried to use it, but we stopped. And we ended up using just the package prefixes because it's very easy to configure and your packages doesn't change often. Plus a set of wrappers on Objective-C side. So all the ugly names and all the ugly classes are wrapped with a nicely API on Objective-C side. Now, project impact. Talking about project impact, I want to mention about performance, because that was one of the key points that was important for us. We didn't do any performance tests on our own, but the guy called Harry Cheng did a perfect comparison of other cross-compilation tools in his Medium blog. And the results was following. J2ObjC was much faster, okay, not much, but it was faster than even Swift in the first versions. It was faster than pretty much any other cross-compilation or native tool. And the main reason for that, as I mentioned, we compile from Java to Objective-C. And all the optimizations are happening when you compile Objective-C to machine code. So J2ObjC allows to use experience of 30 years by developing C++ compilers when optimizing your code. Plus, J2ObjC is doing their own optimizations that adds this difference. If you're talking about memory performance, it's more or less the same. J2ObjC is more or less as efficient as Swift, but the difference is like, there is almost no difference. Talking about memory performance, J2ObjC supports two memory models. First one, it can support memory management via ARC. That is supported by default, or you can handle it manually by specifying explicitly release and other keywords on Objective-C site. But all this is generated for you by Objective-C. Now it's by default to ARC. Talking about size impact. As you can imagine, when you cross-compile your code, to make it work on Objective-C site, all Java API also need to be cross-compiled. And we need to cross-compile also Java runtime environment as well. From our experiments, it adds around 3 megabytes to your file size, which is not that big, especially looking into modern application sizes on iOS that are reaching around 100 megabytes. There are a couple of ways how you can reduce size. First one, you can include only parts of Java runtime environment you use. For instance, if you are not using any of XML tools, you can drop the java.xml package. Java runtime environment emul project is split now into separate projects, and you can use only parts of it. It requires extra setup, but you can save some space on it. Second option is to use Gradle of ProGuard obfuscation. The way how it works, before running J2ObjC, we generate a usage report by ProGuard and specifies the output file to Objective-C, and it knows which classes can be stripped out of the build. One, last but definitely not least, about team impact. Your iOS developers will have much less work. And when I say much less work, I mean like really much, much less work. From our experience, we were working on our Android part of the code for around 2 sprints. It's like 3 weeks. iOS developers finished exactly the same functionality with cross-compiled code in 3 days. 3 weeks, 3 days. Just imagine how many time you can save on this. And at the end, you get perfectly testable code with very small effort. Also, when you're hiring new team members, you have to keep in mind that most part of developers will face with both platforms. If not Android and Objective-C, then at least Java and Objective-C. That means that requirements go up, and you have to look for developers who have experience on both platforms. To sum up, there are some bad things about J2ObjC, particularly about Gradle plugin. It's not supported anymore, but I'm pretty sure that there will be community supporters that will take care of official repo. We are taking care of our own fork. We don't want to claim the official repo because we don't have that much time. We are a small startup. But it's handleable. It's very easy to manage. Like, everyone who knows Groovy can update Gradle plugins. Second, for someone, it could be problems that you can't use third-party libraries. But, as I mentioned, in a clean architecture, you just need to create a boundary between your business logic and framework driver. Just move your third-party library to a framework layer and use it as an interface in the business logic. And there are some problems with unit tests, and unit tests are the only way to validate logic. So you have to write code properly. You have to write unit tests, and TDD is highly encouraged, which takes more time, but at the end, the results are much, much better. On the other hand, there are tons and tons of good stuff. We got super performant tool. From the plots I showed, you can see the J2ObjC overperforms most part of native and cross-platform tools. It's very easy to maintain, because most part of the code is written on Java side, and Java has perfect, or close to perfect, environment. You have IntelliJ IDEA, you have static code analysis tools, you have testing tools, you have pretty much anything that modern development requires.